Hey guys, so today's lesson is 1.2, section 1.2 on line segments and distance. So we're going to start off with what is a line segment? Well, a line segment is something that can be measured because it has two endpoints. Okay, so a line segment can be measured because it has two endpoints. All right, so it can be measured. That's different from a line. A line has no endpoints. A line goes on infinitely, so it cannot be measured. But a line segment we can measure. So with this, in this section, we're getting into actual measurements. All right. So if we take a look at an example of a line segment as opposed to a line. So a line, if you remember, we drew a line that looked like, go ahead and put the arrows on the ends. So when we drew a line, it looked like this, has the two arrows on the ends. And then when we name that line, we use any 2 points that are on that line. So we would call this line AB, or using the symbol AB with the line on top. All right, so that's how we would name a line or reference a line. Notice the two arrows on the ends indicating that the line doesn't stop. It goes on infinitely in either direction. A line segment is different than that. A line segment is kind of like we're taking this line and we're going to chop it off here and here. Okay? Or if you want to look at it in another way, we're going to chop it off at point A and point B. All right, so now we're looking at not a full line. Now we're just looking at just a section of that line or a line segment. Okay? So then when we name a line segment, we would name that the same way, but we would put a segment above the A and the B. Notice the segment symbol doesn't have the arrows on the ends. So it's very important that we distinguish between a line segment or a line using the correct symbol on top. Okay? Next thing we're going to talk about is the betweenness of 2 points. Okay? So I'm going to go on to the next page. And now we're going to talk about what it means to be between 2 points. So if you think about a number line, if you have any two numbers on a number line, you can always find a real number that's between those two numbers. So if I have the numbers 3 and 10, okay, I have possibility of any numbers 4, 5, 6, 7, 8, and 9 that are between 3 and 10. So that applies to numbers or lines as well. All right, so if we look at a line, so let me draw a line up here. We'll put the arrows are already there. So I'm going to draw my line. I'm going to call this line AB. So I'm going to put my 2 points on here for A and B. So here's my line AB. Now when we talk about betweenness, let's put a point right here. So is point N between points A and B? And the answer is yes. It's on the same line that connects A and B, and it's between points A and B. as opposed to point R. R is on the same line, but it's not between points A and B. And what about if we put a point P up here? Well, P is not even on the same line. Even though, if we physically look at it, it looks like it's between A and B, but because it's not on the same line, we can't say that point P is between A and B. It has to be on the line that A and B are both on. Okay? So when we look at being between, what does that mean? What does it mean for a point to be between A and B? It means it cuts that line into segments. It cuts that line into smaller pieces. And so what that means is that if I look at segment AN, and then I look at segment NB, well, combined, those two make up the full length of A to B. So what that means in symbol form is if I take the length of AN plus the length of NB, that has to equal AB. So that's what between this means, and that's what having a point between two other points does for us. It splits that line segment into smaller segments. And the sum of those smaller segments is equal to the whole segment. Okay? So now let's talk about distance. We looked at segment addition. Well, before we get to distance, I want to take a look at, some examples of what this segment addition actually looks like in a problem. So let's look at an example here of segment addition. We're going to use this concept, AN plus NB is equal AB. So let's get us a line here. Actually, you know what? I'm going to make that a line segment. So I'm going to delete that, and I'm going to change my ends to just 2 points. So I'm going to have my line segment AB. So here's my point A. Here's my point B. And I'm going to put a point between A and B right here, and I'm going to call that point M. All right? So from A to M, we have that distance from A to M, we're going to say is 2x plus 3. And then the distance from M to B, I'll put it in a different color. From M to B, we're going to make it 10. But I'm also going to give you the length from A to B. So the measurement from A to B is going to be 15. So my total length of AB is 15. From A to M is 2x plus 3. M to B is 10. So what I want to do is solve this for x. So we're going to use this concept right here, where if I add the two shorter segments together, it equals a longer segment. So I'm going to have my 2x plus 3 plus 10. So I have my AM plus MB. I'm going to write that up here as well so you can see. So I have AM plus MB. Nope, not D. MB equals AB. So now we're going to substitute our values in. I know that AM is 2x plus 3. I know that MB is 10. And I'm told that AB up here is 15. All right, so now we can go to Desmos, plug all that into Desmos and get our answer. I'm going to go ahead and just work this out. So I have, if I combine my 3 plus my 10, I have 2x plus 13 equals 15. Subtract my 13 from both sides. We have 2x is equal to 2. Divide both sides by 2, and I get x is equal to 1. Okay? So let's go back and check. I know that my total length has to be 15. If I substitute 1 in for x, I end up with 2 times 1 plus 3. 2 plus 3 is 5. So I get that length from A to M with 5. And then 5 plus 10 does give me the 15. I'm going to stop this video here. I'm going to do a second video. I don't want these to extend for too long. So I'm already at 11 minutes, so I'm going to stop this one. I'm going to do a second video with the distance formula.